Hi everyone. In today's challenge, we are going to solve this problem kth largest element in a string, and the problem number is 703. So alright guys, so first of all what we are going to do, we are going to clearly understand what this problem say. After that we are going to move to the logic part. We are going to see how we can solve this problem, and after that we are going to move to the implementation part. We are going to implement our logic in C++, Java and Python programming language. Fine guys, now let's see what this problem say, right? So it is an easy level problem first of all, so it will not going to take much time, right? The problem says design a class to find the kth largest element in a string. So one thing is clear, right? What we have to do, we have to design something, right? So it is a design problem, right? Okay. And second line says note that it is a kth largest element in the sorted order, not the kth distinct element. So guys, what say the first line says we have to design to find a kth largest element in a stream. So let's take a stream, right? So let's take, I have taken this stream. So now guys, what we have to do, we have to find the kth largest. So what will be here? If I say tell me the third largest, case 3, so give me the third largest element, so which will be nothing but 4, right? You will say me 4, and it is fine, right? Now what they mean by then this, but kth largest element in sorted order, not the kth distinct element. So they mean by like this: if the stream look like this, 2 3, and if I say 4 5 5 and 6. So now guys, what will be the third distinct element in this? So you will not say like 6, 5 and 4, because 4 has come twice, but still it is the one, right? You will say 4 again, right? Or you will say 5. So here the right answer will be 5, right? Because it should be in sorted order. No matter a number coming twice, so it will gonna say this is the second largest, this is the third largest. Even the number is same, but the order will remain same, right? So we have to check the order. So this is the first largest element, second largest element, this is the third largest element. I hope this makes sense. So that was the two line says. Now let's see what we have to do. Implement a kth largest class. So alright, so we have to implement this class. So, and this class will be given to you in the editor, right? But there is one constructor kth largest int k and nums, right? Nums is an array, right? Alright, so initially we are given the some stream as well. So initialize the object with k, integer k, and the stream of integer nums. Fine. So one thing is also clear that we are given the one array and one k value in a constructor, right? So what we have to do, we have to know that we have to return kth largest element. And first of all, we are given some we can say default stream, so we have to also find from there as well, right? After that, int add. So here we have given the one argument only, that is value, and append the value to the stream and return the element representing the kth largest element in the stream. Now guys, let's summarize this two line easily. So first thing is we are given the constructor where what we have to do, we have to given a nums array, right? And k is nothing but which we have to find kth largest element from the nums array, right? After that, we are given the one function which is value. So now in this function, what we have to do, we have to add this value in this nums array. Now we have to return the kth largest element. We don't have to return any, and actually we don't do anything constructor, right? So in this function we have to return the kth largest element after adding this value into your nums array. So I hope this makes sense, right? So now you can easily you can see this particular example. So in this example, what you can see we have this particular initial nums array. So let's understand the problem here with the nums array. So we have 4 5 8 and 2, right? So we have initially this nums array and case 3, right? Fine. Now what we have to do, in the next add function they have given 3, so we have to add this 3 in this particular array. So let's say I have added in the last, right? Now what we have to do, we have to find the third largest element, which will be nothing but what you can say, the first is 8, second is 5, and the next is nothing but 4, right? So third largest element will be 4. Fine. Then we have to add 5 into this. So let's say I have added 5. So now what will be the third largest? 8, 5 and 5. So it will be 5 only. You can see the output as well, 4 5. After that they say that add 10. So if I add 10 as well, so now my third largest element still will be 5, because first is 10, second is 8, third is 5. So you can see third output is also 5. And then we have added 9. Now if I add 9, then first largest is 10, second largest is 9, third largest will 8. So you can see output is 8. Then I have added again 4. So if I add 4, then first largest is again 10, second largest is 9, then third largest is 8. So your answer is 8. So I hope guys now you understood the problem, right? So we have gone through this particular example with this problem statement. So I hope you understood it. Now if you understood the problem part, if you understood this problem statement, then let's move to the logic part, right? So now let's see how we can solve this particular problem. So guys, for solving we don't need anything just except one data structure, nothing else. We don't need any more data structure. Only one data structure will do our job. So that is nothing but heap. And why heap? So let's understand the logic behind this. So there is something which is happening here and which we don't need, right? So if you have noticed this 4 5 8 and 2, right? So if you have noticed this particular thing, and if you have noticed the last example, if I do scroll back, just give me a time, we have seen a last example, very interesting, right? Here if you will see, right, in this example, Okay, let me take this. So in this example, guys, we have added till 9, right? And our output was nothing but 8 only, right? It was 8. I hope it makes sense. Now after that, I have to add 4. If I'm adding 4 into this, does it affecting my output? It is still 8, right? Because the bigger number are already same. It will be 10, 9, and 8. So can we say that the number after this 3 number is not going to impact us? So even if I add 2 again, so it will again give me 8. Focus over here, guys. It's an important part. If my main number was what, 10, 9, and 8, right? After that, what I have done, I have added a 4. Doesn't matter, it's still gonna give me third largest 8. If I add anything less than 8, it will still gonna give me 8 only, right? So can we say that if whatever the number present here doesn't matter for us, right? So we can simply remove them. So let's solve this particular example only. Let me write here logic only, and you will see what I mean by this. So we have initially this 4, 5, 8. Now focus over here. So it is going to be really important part for you. And if you understood what is happening, if you understood this particular one, then definitely I would say that it is a very easy problem, right? Even it is easy, right? So we have initially this particular array 4, 5, 8, right? Now what I'm going to do, I'm going to add 3, but before that I'm going to say case 3, right? So only keep 3 bigger element, so which is nothing but 4, 5, and 8. 2 is not a bigger, so we can simply move it, right? Fine. Now it says that add a 3, so we are going to add into 3, right? So I have added 3, but now again, once I added, now I have to keep 3 only bigger. So which is nothing but 4, 5, 8. So I can still remove it. And I can return the topmost element, that is nothing but top minimum element, that is nothing but 4, right? So see what I have done. When I have added 3, I have to check. Take out only 3 bigger element, rest you have to remove it. And once you have take out, just return the smallest one. So you are going to return 4 also. Again there is add 5. So I have added 5. Now once I have added 5, now what we have to do, we have to just take out only 3 bigger number, and rest I have to delete it. So here 3 bigger number is only this, so I have to delete 4. And what is the smallest number? That is nothing but 5, so I can return 5, right? And again I have to add 10, so I have added 10. And now I have to remove the number which is not in our first three element, right? So first three bigger number is 8, 5, and 10, so I can remove 5, right? Now the smallest number is 8. Now again I have added 9. No, smallest number is 8, not it's 5, right? Again I have added we can say 9. So if I add a 9, so it will come like here, and the bigger number are 10, 9, and 8, so I can remove 5, right? And the smallest number here is 8. If I added 4, I added 4. Now bigger number are 10, 8, and 9, so I can remove this one, and the smallest number is nothing but we can say still 8. So guys, now you can say that it is going to take a lot of time complexity, right? We are just removing first of all, then we are deleting it, right? And then we are finding a smallest one. So for that we can use a heap, right? Min heap is going to do our job. How it's going to do, you can see, like initially in our min heap was 4, 5, 8, 2. So I'm just going to pop all those elements uh, mini, but it will do, first of all, tell me it will gonna give us this minimum element, right? So first time it's gonna give 2, then it's gonna give 4, then it's gonna give 5, then it's gonna give 8, right? So what I can do, I can say just traverse till the keep this 3 element, right? So if the size is 4, then you have to 4 minus 3 means you have to remove one element from there, right? So we are gonna start a loop for one time, and we are going to remove the minimum element. We are going to say heap dot pop, right? We can say dot pop, which is going to remove the element, and that definitely will be the minimum one, right? So we don't need to care about minimum. And at then when we are finding the minimum one, we don't need to find, we just need to say return heap dot top, which is going to give us the minimum element. So everything is going to done in log of n time complexity. Like the heap, I will say the whole time complexity will be big of n, right? It is going to be big of n, and it maybe go above. Let's check out. So first of all, what we are going to do, we are going to inserting all this in heap. So it's going to say n log n. This, if I'm considering this nums length, so it's going to be n log n, right? Because we are traversing over there and we are inserting into a heap. So time complexity will be go till n log n. It will not go more than this. So let's go more with our implementation part and see how we can solve this particular problem. So guys, I'm here in Python, and first of all, what we are going to do, we're going to see how we can first of all initialize a min heap, right, in a Python, and what we can do after that, right? So first of all, I'm going to say self dot min heap. I'm going to create self dot min heap. All right. So I have done this particular thing, not heap. Now, guys, what we are going to do, first of all, tell me just what we are going to do. We are going to say nums dot. First of all, let me take all these things nums, right? And after that, we have a min heap array right now, right? Now I'm going to heapify it. So I can say heap u dot heapify, and here what I can say, I can pass this self dot min heap, right? Once I have done this particular part, it has created this min heap tool. this min heap array to a actual min heap, right? Once we have min heap, we are going to say self dot k, which is going to be equal to k only, right? After that, what we are going to do, we are going to say for I in range of length of this nums minus what I can say length of this minus k. So which is going to give me all the number which are not important for us, right? So we can say directly remove them. Heap q dot heap o, right? There is a function with heap o which is going to remove from this self dot min heap. Fine. Once this is done, we are going to come to our add functions. Now we have only all the we can say if k is 3, so we have only 3 bigger element, right? So 3 larger element is there. We are going to insert this particular as well. So self dot heap, not heap, we can directly say heap q dot heap push, heap q dot heap push, and we can pass our self dot min heap, right? And what we have to push, that also we have to check it. We have to check is well, right? So we are going to push heap q inside this min heap. We are going to push this particular value. Once we have pushed this value, what we are going to do, we are going to check it, or we can say we are going to remove the smallest one, right? So we can say for this is not a C++, so we can say for I in range of length of again this we can self dot min heap minus k, and which is self dot k, right? So we can say just remove the smallest element. So we can say heap q dot heap, we can say pop, right? And after that we can pass by self dot min heap. So this is going to do our job. After that we can say return self dot min heap, and here of 0. So what is this? This is the smallest element in our min heap. So let's try to run this code and see whether it's working fine. So I hope guys you are getting it what we have done, right? So what's first again, here is the there's no heap q. All right, so there's no heap q, so don't worry, we are having a heap q should be there, right? So we have to import, let's say we have to import heap q. All right, so not it's saying heap q, it's saying the heap pop, right? So we have to say heap pop, right? So we don't need to import it, it's by default there. So basically there is a function with heap pop, not heap pop, right? All right, so now let's see. And basically what we are doing here, you can see first of all, let's see the test case. You can see test case pass. So basically what we are doing here, we are saying first of all create a min heap. We have created a min heap. After that we have removed all the element which are smaller than we have only taken all those elements which are bigger, right, of k size. Rest we have dropped it. After dropping it, we are inserting this in our heap, and after that we are removing an extra elements, and after that we are just returning the minimum value, right? And let's try to submit this code. And I hope guys it is very easy, right? So we are just using a min heap, nothing else. We are not sorting it, we are not doing anything else. Well, let's so you can see that we have successfully submitted with Python. Now let's move to the next programming language quickly, that is nothing but Java. Or let's take it C++. So in C++, first of all what we are going to do, we are going to say private. Let's make some variable private, and this is going to be nothing but first of all we are going to say int k, or we can say int length, which is initially nothing initialized. And after that we are going to define a, we can say min heap, right? So min heap, how we can define it? We can say priority q, and here we can pass our integer data type. Then after that we can pass our vector of int, and after that we are going to pass greater of int, right? So once we have initialized the priority q means min heap, so here we are going to say first of all let's say this dot l should be equal to k. After that we are saying that pq, so we are going to say for int value in nums pq dot push this particular value. Once we have inserted all these things in our heap, now we are going to remove all the unnecessary values. So we are going to say first of all get the size, int size is equal to pq dot size, which will be initially the size of nums, right? And after that we are going to say for int I is equal to 0, I less than size minus l, not l, you can use a k as well, size minus k, and I plus plus. What we are going to do, we are going to say pq dot I hope it makes sense, right? So once this is done, we are going to come to the add function. Here we are going to insert first of all this pq dot push val. After that we are going to say int size is equal to pq dot size, and we are going to use the same loop for int I is equal to 0, I less than, that means I is equal to 0, I less than s minus, and here is l and I plus plus. And here we are going to say pq dot pop. Once this is done, we are going to return the topmost element, so which is nothing but pq dot top. Now let's run this code and see whether it's working fine or not. So if it is working fine, so I will summarize this particular code as well. And here you can see, let me see, you can see both single test case was there and it accepted. So what we have done, first of all we have initialized the queue, not in queue, priority queue means min heap. And after that what I have removed the unnecessary values. And after that what we have done, inserted this in our queue, this value, right, in min heap. And after that what we have done, we have removed the unnecessary values. Then we have written in the top, which is nothing but smallest, right? So let's try to submit this code as well. And I believe it will also get submitted, right? So logic was same, right? Now this is also done. Now let's move to the Java, right? Java, in Java, what we have to do, we have to first of all initialize the priority queue, right? So we can say directly here, priority queue. And here data type will be integer, and in this name I'm going to say pq new priority and queue, right? And we can also do like this. Fine. After that I'm going to initialize a length which is going to be nothing but L. Now here what I'm going to do, I'm going to say length is k, and for int value in nums, what I'm going to say, I'm going to say pq dot push, right? Not push, we can say here offer, right? And here we can pass value. Once this is done, what we are going to do, we are going to remove the unnecessary, right? So fill int I is equal to 0, I less than pq dot size minus, and what is this? This is going to be nothing but k I plus plus, right? Here we can say pq dot whole. All right, so once this is done, we are going to come to this part. We are going to say for first of all, we are going to insert this pq dot offer this particular value. We are inserting this particular value in our priority queue, and after that we are going to say remove unnecessary things. So for int I is equal to 0, I less than pq dot size minus L and I plus plus, right? Once this is done, we are going to say pq dot. First of all, let's pull this here. After what we are going to do, we are going to say return pq dot, and here we can say peak, right? So let's run this code, see whether first is working or not. So it is Java, right? And I don't want to get any error in Java. Let's see. I got it. Again, I got it. And here I used to use colon was there, right? I have to use semicolon. All right. Now let's see. You can see the test case accepted. Alright, so now first what we are doing, where we are initializing a queue, we are inserting all the value in our queue. After that, removing unnecessary values. And after that, what we are doing in add function, first of all, pushing this particular value in our queue, priority queue. After that, we are just popping it all the necessary value, because here will be at max 1, or at max 1 could be there, at least 0 be there, right? So this loop sometime will not work, this sometime will work, right? After that, we are returning the smallest one. So this was the simple logic, right, guys? We have already seen this 4 step in our logic part, and also here in implementation part, and we have successfully implemented in C++, Python, and now let's see with Java as well, I guess. So let's get it submitted, right? What happened to it? It is a wrong answer, right? And let me see with what happened to it. So do we have done something wrong here? I guess we haven't done, right? So this is the last test case, even though, but still I have to find what I have done. So here L was this k, right? And after that we are moving to this nums, and we are inserting this thing, right? Fine. And after that, what we are doing, we are returning the dot size of L, and int I0, I less than size of k, and I plus plus. I'm just popping it out, right? So what it has done wrong is, he has, let's take it this test case here. Let's try to run this code test case. So we have to now debug it, nothing else, right? And I guess it also should submit it, right? So it's same as it is, right? So it is basically doing something wrong. We have done something wrong here. If you guys can figure it out, just let me know in the comment. Otherwise, I'm just seeing over there. And just what we are doing, we are just traversing this. We are taking a size. And if I do like this, int value, okay, not value, if I say size is nothing but this, and if I say into v minus l, and I can put in this bracket as well, right? And here also, if I can say int not pq dot size, if I say nums dot length, right? Okay, and if I do like this, num dot length minus k, let's run this code, see and whether it's working fine or not. And here I got an error. Why v? Not v, it should be s, right? Let's see whether it's working fine or not. And there's no num dot length. You can see what task is passing, right? So let's try to submit this code now. And I have got an error as well, and also one submission error in Java, right? That's why I say. So you can see that, guys, we have successfully submitted in C++, Python, and Java, right? And if you learned something new in this video, don't forget to hit the like button, and don't forget to subscribe as well, right? So meet you in the next video.